This lesson is perpendicular bisectors, and then on the backside we're going to talk about angle bisectors. Theorem states if a point lies on the perpendicular bisector of a segment, which is this guy right here, then it's equidistant from the endpoints of the segment. In other words, if you've got a perpendicular bisector that hits the opposite side at a 90, it's going to cut this opposite side in half. So AD is going to be congruent to DB. All right. And then we also know this. If these two pieces are congruent to each other, the sides of this triangle are also going to be congruent as well. So I can say AC is congruent to CB. And then this just talks about the converse, just flips it basically. If I have congruent sides of a triangle, then I also know that the base pieces are also going to be congruent. All right. So if AC is congruent to CB, then I know that CD is perpendicular right here to AB. And then I can say that the bottom pieces are congruent to each other. AD is congruent to DB. All right, some examples. Number one, all right, since I have congruent base pieces cut by a perpendicular bisector, I know that this piece is congruent to that piece. So set them equal, solve for x. 7x plus 24 is 13x minus 48. I'll subtract 7x from both sides. I'll add 48 to both sides. And 6 goes in there 12 times. Number two, same concept. Congruent sides, congruent bases, set them equal. 17x minus 3 is 9x plus 13. Subtract 9x from both sides. Add 3. X 8 goes in there 2 times. Number 3, same concept. Congruent bases, congruent sides. Set them equal. Then we got to find RS, plug it back into this piece right here. 7x minus 22 is 4x plus 5. Subtract 4x from both sides. Add 22. 3 goes in there 9 times. Plugging it back in, that comes out to be 41. 4, same concept. Congruent sides means congruent bases. Set them equal. 2x plus 11 is 14x minus 37. I'll subtract 2x from both sides. Add 37. Divide by 12. That goes in there 4 times. And then finding EG, that piece right there comes out to be 19. 5, same thing. Congruent sides, congruent bases. Set them equal. 5x minus 11 is 3x plus 17. Subtract 3x. Add 11. Divide by 2. 14. Find AB. So basically, you can plug it into one piece and multiply by 2, or plug it back into both and then add them up. So I'm just going to plug it into here and then multiply it by 2. If you do that, that comes out to be 118. So from A to B is 118. Number 6, congruent bases means congruent sides. Set them equal. 6x minus 26 is 3x plus 34. Subtract 3x. Add 26. And 3 goes into 60 20 times. It says find JK. Plug it back in, 94. All right, backside, we're going to talk about angle bisectors. Theorem states, if a point is on a bisector of an angle, then the point is equidistant from the sides of the angle. In other words, this. If I have angle bisection going on right here, that means that this piece is going to be congruent to that piece. So if AD bisects angle BAC, which is that guy right there, AB is perpendicular to BD, and AC is perpendicular to CD, then I can say these two pieces are congruent. So I can say BD is congruent to CD. And then the converse, basically the same thing up here, guys. Going through all that, if I have congruent bases and the sides are perpendicular to the base, I know that this angle is going to be congruent to that angle. So I can say angle BAD is congruent to angle CAD. All right, examples. Angle bisection, congruent bases, set them equal. 4x plus 30 is 9x minus 5. Subtract 4x from both sides. Add 5 to both sides. Divide by 5, x is 7. Congruent bases means congruent angles, set them equal. 5x minus 11 is 8x minus 41. Subtract 5x. Add 41. And then 3 goes in there 10 times. Number 3, congruent angles, congruent bases, set them equal. 13x minus 4 is 8x plus 11. Subtract 8x. Add 4. 5 goes in there 3 times. Then it says find AD. Just plug it in. That gives you 35. Number 4, congruent bases means congruent angles. Set them equal. 8x minus 32 is 3x plus 3. Subtract 3x from both sides. Add 32. X comes out to be 7. And it says find angle XWZ, that guy right there. Plug it in, comes out to be 24 degrees. Number 5. Congruent sides, congruent angles, set them equal. 2x plus 20 is 5x minus 37. I'll subtract 2x from both sides. Gives me 3x minus 37. Add 37 to both sides. And then 3 goes in there 19 times. Our job is to find angle FGH. FGH is this whole thing. So I plug into both, or I could just plug into one, multiply by 2. Either way you do it. If you plug into both, or plug it into one and just times it by 2, it comes out to be 116. Congruent angles, congruent bases, set them equal. 7x minus 40 is 5x minus 8. Subtract 5x. Add 40. 2 goes in there 16 times. My job is to find QR. So QR is that piece over there. Plug it in, 72. That's it for angle bisectors and perpendicular bisectors.